Hello, everyone. Today I'll be focusing on the chess robot simulation, mainly on the aspect of integrating um, the task planning aspect, wherein we plan for different scenarios of the in the chess game. So previously in the last video, we had seen the robot was able to move on the basis of the command given by Stockfish AI. But over there, we didn't integrate the pick and place. Also, we didn't do for the two situations, which are uh, capture and castling, which means that we can't directly use the notation which comes through, and we have to add on layers of logic in order to execute a capture move or a castling move. Let me explain that a little bit more better in the upcoming slides. So, just to recap, this is the setup we had set up. We had wherein we just give a start command, and then the task planning plans requests for the chess AI service. Chess AI service gives the chess move, and then the task planning does the planning in the sense that it just gets a move saying that which square, where does the robot have to move from square and the to square, and that has to convert it into the robot pose, and then the robot path planning service moves the robot. So this was covered last time, but here we didn't enable the pick and place. Um, Mainly because of few reasons. In the previous state, we had a situation where the pick and place were not defined as a function. More or less, it was just that the posts were sent and the robot just moved to those particular poses. And these poses were determined using the task planning. Uh, to enable pick and place for different situations, we have to uh, abstract, get some abstractions, as then we have to make a function which is just for pick, and we have to make a function just for place. And then we we have to have an abstraction of open gripper and closed gripper, and then also we need to have a function which tells you how much, what the joint value should be given the particular piece you want to move. And also the gripper, what height it has to be given the particular piece. For example, for a king, you need to pick it up a little bit higher compared to a pawn. So that's the difference for two different pieces. So for the two different pieces, you need to have different joint value for the gripper so that it doesn't grip in too tight. And also it needs to have a proper height pushing so that it catches the chess piece at the proper position. So by getting this abstraction, we can now call these functions for different cases. Um, as in for a capture situation, the command which we receive from the chess AI would be something like e4 to d5, which is just the move of one particular piece. But then we also get a signal saying that it's a capture move or not. So using those two as the input, what we try to program is that um, with this input, we are able to derive two different moves, and then we execute them systematically. Um, the problem here is that we can derive the first move, which is to just take the piece out of the board. So here, this would be d5 to I1. And this d5 is basically the square the current chess piece has to move to. But the I1 is derived through another function where we basically utilize these sides. We add additional columns to the sides. We give two columns to the left side and the two columns to the right side. Uh, and then so that we can place these captured pieces in a more systematic way so that we can access them when we need. So, for example, I1 here represents that the I represents the first column for whether it's a black piece or a white piece, and 1 represents uh, the number of pieces it has captured. So if it's 6 pieces it has captured, it will be I6, and if it has captured 10 pieces, then we move to, instead of I, we go to J, and for 10 pieces, we have it divided, we have it subtracted by 8, and then we have 2. So we would get J2. So in this way, even if all the chess pieces were captured, we have them arranged systematically on the sides of the chessboard. This is done so that in cases where in the end game where a pawn goes on to become a queen, we need to retrieve back a queen or a rook, whatever the person decides he wants. So in order to do that, we need to have it systematically arranged, and this is the logic which I had programmed in Python to make that happen. So these are the two major programming updates I had made. And all the details of the program is there in the GitHub, and there is comments for each and every methods, which you can go through and understand. So, in case for castling, that's another scenario wherein you just get, for example, E1 to G1, which is just the movement of the king, but you don't not get the movement of the rook, which would be H1 to F1. So, if we need to make this work, what we do is that in this scenario where the input says that this move represents a castling move, we utilize that, and then we derive subsequent moves. That is that we make E1 G1, which is just one move, into two different moves, which is E1 G1 and H1 F1. So I implemented this using dictionaries. You're free to do it how you want, but this is how we deal with the scenario of castling. So these were the two uh, major cases wherein it's a capture and wherein it's a castling. So these are two cases where it's quite difficult to handle, and we have to add in logics in our program in order to make this happen. So in this package, I had done the path planning using C++, and then the task planning using using Python. So yeah, these changes were done in C++ and Python respectively. And apart from this, I did face a lot of problems with regards to the grasping for different pieces I needed to pick. So some things which I learned on the way were that my collision for the chess piece was not set properly, and because of that, I was not able to grab these pieces uh, and move them. So for the grass plugin to work, the collision has to be set properly. Only then it would work. As because only during collision, the grass plugin turns on and then it grasps a particular piece. And the next thing was that like by making functions more modular and by separating each major functions into its own methods, we can do more larger things um, uh, very easily. So these were two things which I took away while doing this, while implementing this particular change. And this is the simulation at the end where um, the robot is just playing like a normal person would do, and it's able to understand that this is a capture, and so you need to take the uh, the black piece which is on in its way, keep it outside, and then move it. And it does it in such a way that it keeps these captured pieces in a respective place so that it can retrieve even later. So this is the end of like the simulation part of it. Um, and the next steps which I plan to work on is to get the gripping working better for all of the pieces. Right now, I do find that at some points it's not able to grip the chess piece properly. It slips. So I need to figure out um, what is the right gripping joint angle and what is the right height so that the gripping works all the time. And also, I'm planning to introduce the cameras to perform a state detection wherein it has an understanding of where each piece is, and then I can use that to decide on the next move. So these are some things which I'll be working on. And thank you for following. If you have any questions, please feel free to comment down below, and yeah, follow the YouTube channel so that you can get future updates. Thank you.